Hello guys, today we are gonna study about splines and how can we use splines for interpolation. So basically before starting splines I want to discuss what is interpolation. Interpolation is basically to find out the value between the given set of data points, or we can also extrapolate it. So for this purposes we use interpolation. So let us do interpolation using quadratic splines. Before going to quadratic spline, I will be giving you an idea about linear splines. So let's start up with some. So why splines? Splines we use because to get our value closer to the exact function. That as here you see the exact function is drawn with a blue line, and I have drawn a fifth order polynomial and it's a spline, and you see that it is close enough with the exact function. So that's why we use splines to interpolate our values. So here the same thing is shown, and the basically what here is shown that higher order polynomials are not good. Like you see that the exact function is this, fifth order is with dotted line, and 19th order is so much with the dotted line is so much error that you can't even see them. You have seen this, so that's why it is good idea to keep it short, up to third order, fourth order, maximum fifth order polynomial. What is linear spline? Linear spline is just joining the data set of points and interpolating the values between those points. It is a good idea, it is short method, but it has carried a lot of error inside it. So that's why we usually do not, it's not a good idea to use linear interpolation. So here it's an example, t is given, velocity is given, we have drawn the points, we have joined the 2 points, we have just used the formula, we have to find the velocity at t, and we have used the values and then substituted the value of t, and we have got the velocity at 16. So this is the linear interpolation, which is not a topic, but we are going to study quadratic interpolation. What is quadratic interpolation? Quadratic interpolation is joining the points but in a quadratic manner. It's not a straight line, it's a curve. So how can we fit the data within a quadratic splines? Here we see it. So let there will be n number of data set of points. So we know that between a spline there are 2 points which joins a spline. So let it be x0 and x1. So and similarly the another spline x1 and x2, and then another spline x2 and x3, and so on to xn minus 1 to xn. So here a, b, c are unknowns. We have to find the values of a, b, c, put in them in equation, and then interpolate our value for unknowns. So what is quadratic spline in depth? Let us say that there are 6 set of data points given. So we will see that in example. So here we are going through the equations, and then it is the major part of quadratic splines, in which the point at which the 2 quadratic splines meet are called interior points. We take the derivative at that point of the first spline, we take the derivative of at that point on the second spline, we equate them, and we got another equation. And in this way we complete our equation, find the unknowns, and find the interpolated values of unknown values. So here is the method. Now let us start. The same thing is depicted over here. The 3n is the number of unknowns in each equation of 3, and we have to find that how many splines are being used to find the value, and in this way we find that we have joined the 2 points, we have just used the formula, we have to find the velocity at t, and we have used the values and then substituted the value of t, and we have got the velocity. I told you that at each interior point the spline 1 is meeting with spline 2. If I take the derivative of the first spline at that point and the derivative of the second spline at that point and equate them, I will get the slope continuity at that point. By using this law, which is C1 continuous, by using this law I am doing the remaining 4 equations. which are given by this. Again, and the last equation, I am assuming that the first spline is linear. I am taking the double derivative of the equation, equating it to 0, and I got the variable a1 is equal to 0. Now what I have to do with these 15 equations? The pointwise is. So you can see the graph, you can see the equations. Now I will make a matrix of 15 cross 15, and then I will find the unknowns a1, a2, a3 and the other unknowns, and then put the value, and I will see that my unknown value is in which piecewise defined function, and then put the value in that equation and find my answer. So by solving this matrix, I obtain the values of unknown a's, unknown b's and unknown c's. I will put these values in the spline equation, and then I will use my equation to interpolate the value at 16. Now here is the catch. What is the catch? That I see that my unknown value is lying between 15 to 20. So I will use the spline number 3 to find my interpolation. So what I have done, I have gone to equation number 3, I replaced the value of t with 16, equated it, and then I have got the velocity, which comes to be 394.24. You would be thinking why I have covered linear splines. I have covered linear splines to show you the error. The error you see is 0.1369%, which is very little. It is okay, we can use it. Thank you guys.